question relates to understanding the type of covers used with FS electrical boxes as referenced in NEC Table 314.16a. However, the table itself does not directly specify the type of covers that are exclusively associated with FS boxes. Determining the correct cover for an FS box requires considering several factors, including the intended application, the environment, and the specific requirements outlined in the National Electrical Code, or NEC. FS boxes, which stand for Fitting Standard, are a type of cast metal box commonly used in electrical installations, particularly in industrial and outdoor settings, due to their robust construction and resistance to corrosion. They are frequently used as junction boxes, pull boxes, or to house electrical devices. The selection of the appropriate cover is crucial for ensuring the safety and functionality of the electrical system. Firstly, consider the environmental conditions. If the installation is located in a wet or damp environment, a weatherproof cover is essential to prevent moisture from entering the box and causing corrosion or electrical faults. These covers typically have a gasket to create a watertight seal. Secondly, think about the application requirements. For example, if the FS box is being used as a junction box, a blank cover is appropriate. If it's housed in a device such as the switch or a receptacle, a cover designed to accommodate that specific device is needed. Thirdly, always refer to the National Electrical Code for specific requirements and guidelines related to electrical box installations. The NEC provides detailed information on box fill calculations, conductor sizing, and all the critical aspects of electrical work. NEC Table 314.16 plays a critical role in determining the maximum number of conductors permitted in an electrical box. This table specifies the volume allowance for different conductor sizes based on the size and type of the box. Ensuring compliance with box fill requirements is crucial for preventing overheating and potential electrical hazards. To correctly apply Table 314.16a, follow these steps. 1. Identify the type and size of the electrical box being used. 2. Determine the number and size of all conductors entering the box, including equipment grounding conductors and bonding jumpers. 3. Refer to Table 314.16 to find the volume allowance for each conductor size. 4. Sum the volume allowances for all conductors in the box. 5. Compare the total volume allowance to the internal volume of the electrical box. The total volume allowance must not exceed the internal volume of the box. In addition to conductors, other items such as devices, internal cable clamps, and equipment grounding conductors must also be considered when calculating box fill. Each of these items has a specific volume allowance that must be added to the total. For example, each device, such as a switch or a receptacle, counts as 2 conductors based on the largest conductor connected to it. Internal cable clamps also require a volume allowance, as specified in the NEC. Furthermore, equipment grounding conductors and bonding jumpers are typically combined and counted as a single conductor based on the largest equipment grounding conductor or bonding jumper entering the box. Now let us turn to other relevant NEC articles. NEC Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. This article provides detailed requirements for the installation and use of these components. Key sections within Article 314 address box fill calculations, box mounting, and the use of approved fittings and connectors. For instance, Section 314.16 outlines the rules for calculating box fill, including the volume allowances for conductors, devices, and other items. Section 314.17 addresses the use of approved fittings and connectors to ensure proper grounding and bonding. Section 314.27 covers the requirements for outlet boxes used to support ceiling suspended fans. Adhering to these requirements is crucial for ensuring the safety and reliability of electrical installations. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to quickly trip and de-energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, minimizing the potential for voltage differences and shock hazards. NEC Article 250 provides detailed requirements for grounding and bonding. Key sections within Article 250 address the sizing of grounding conductors, the methods for connecting grounding electrodes, and the requirements for bonding metal enclosures and equipment. For example, Section 250.122 outlines the requirements for sizing equipment grounding conductors based on the size of the overcurrent protection device protecting the circuit. Section 250.50 covers the requirements for grounding electrode systems, including the use of ground rods, ground rings, and metal water pipes as grounding electrodes. Section 250.92 addresses the requirements for bonding metal enclosures and equipment to ensure electrical continuity. Following these requirements is essential for creating a safe and effective grounding and bonding system. Different types of electrical boxes are available for various applications. These include metallic boxes, non-metallic boxes, and special purpose boxes. Metallic boxes are typically made of steel or aluminum and offer excellent mechanical protection and grounding capabilities. Non-metallic boxes are made of plastic and are corrosion resistant, making them suitable for damp or wet locations. Special purpose boxes are designed for specific applications, such as floor boxes for receptacles or device boxes for surface mounting. Each type of box has its own set of advantages and disadvantages, and the selection should be based on the specific requirements of the installation. When selecting electrical boxes and covers, consider the following factors. 1. The environmental conditions. 2. The type of wiring method being used. 3. The size and number of conductors entering the box. 4. The type of devices being installed. 5. The applicable codes and standards. Choosing the right box and cover is crucial for ensuring the safety and reliability of the electrical system. Now let's discuss some common types of electrical box covers. Blank covers are used to cover unused or abandoned electrical boxes. Device covers are designed to accommodate switches, receptacles, or other devices. Weatherproof covers are used in wet or damp locations to protect electrical connections from moisture. Raised covers are used to extend the mounting surface of the box, allowing devices to be installed flush with the wall or ceiling. Each type of cover has its own specific purpose, and the selection should be based on the intended application. To install an electrical box cover correctly, follow these steps. Firstly, ensure that the power to the circuit is turned off at the breaker. Secondly, prepare the wires for connection by stripping the insulation and twisting the strands together. Thirdly, connect the wires to the device or terminal in accordance with the wiring diagram. Fourthly, mount the device or cover to the electrical box using screws or other approved fasteners. Fifthly, test the installation to ensure that it is working properly. Always follow safety precautions and consult the National Electrical Code when working with electrical systems. Conduit bodies, also known as conduits, are fittings used to provide access to conductors in a conduit system. They are available in various shapes and sizes, including LB, LL, LR, and T configurations. Conduit bodies allow for changes in direction, provide access for pulling conductors, and can serve as junction point. They are commonly used in industrial and commercial electrical installations. When selecting conduit bodies, consider the following factors. 1. The size and type of conduit being used. 2. The number and size of conductors entering the conduit body. 3. The environmental conditions. 4. The applicable codes and standards. Choosing the right conduit body is crucial for ensuring the integrity and functionality of the conduit system. NEC Article 314 provides detailed requirements for the installation and use of conduit bodies. Key sections within Article 314 address the allowable fill for conduit bodies, the use of approved fittings and connectors, and the requirements for grounding and bonding. For instance, Section 314.16 outlines the rules for calculating the allowable fill for conduit bodies based on the size and type of conductors. Section 314.17 addresses the use of approved fittings and connectors to ensure proper grounding and bonding. Adhering to these requirements is essential for ensuring the safety and reliability of electrical installations. The term RS cover is not specifically defined in the context of electrical box covers within the NEC. Without further context, it's difficult to determine what type of cover this refers to. It's possible that RS is a manufacturer-specific designation or a term used in a particular region or industry. To determine the type of cover, consult the product documentation or contact the manufacturer for clarification. In summary, while NEC Table 314.16 is essential for box fill calculations, it does not specify cover types for FS boxes. Cover selection depends on environmental factors, the intended application, and adherence to the NEC. When in doubt, consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and standards. Remember to always prioritize safety when working with electrical systems and to follow all applicable codes and regulations. This information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work.